Hi everyone, Mr. Letter here, and today we're going to finish the lesson that we started in class on Thursday and Friday, December 10th and 11th. We're going to finish going over how to name and write the chemical formulas when the metal is a transition metal, and we're also going to learn about how to write the names and chemical formulas when a polyatomic ion is involved. Remember what those are too. So just a quick reminder, transition metals, we have this weirdness because they can have more than one possible ion. And so when we write the name of the compounds that have transition metals, we have to include a Roman numeral that says the charge on the metal. So copper 1 chloride versus copper 2 chloride, for example. Copper 1 chloride has a charge of +1, and so the compound it forms is CuCl. Copper 2 chloride has a charge of +2 on the copper, and so the compound it forms is CuCl2. So quick reminder, this is how you figure out the Roman numeral that you're supposed to use. If you are given the chemical formula, you're going to do a reverse crisscross, check if the anion, the nonmetal charge is correct, and if it is, then put the charge that's on the metal in parentheses next to the metal. If it's not, then multiply all of the subscripts by the same number and write the charge on the metal in parentheses next to it. So we did a couple of these in class, at least on A day. HGF is going to be mercury fluoride. And to figure out what goes in the parentheses, going to do a reverse crisscross. The charges go up, the subscripts go up and become charges on the opposite atom. Hg is first, meaning it is the metal, and so its charge is positive. Nothing written down next to fluorine means that the number is 1. Fluorine is the nonmetal, so it is negative, and nothing next to the fluorine means that the number is 1. And check your periodic table. You find that fluorine is in group 17, and that means that it has a charge of -1, so that charge is correct. So we're going to put a Roman numeral 1 in parentheses next to mercury. And there we go. That's done. Mercury 1 fluoride. Same process for Fe2O3. Fe is iron. Iron is a transition metal, so we need our parentheses. Oxide. And reverse crisscross. Fe has a charge of +3. O has a charge of -2. Oxygen is supposed to have a charge of -2, and so the 3 next to iron is correct. Roman numeral 3 in the parentheses next to iron, iron 3 oxide. FeO and PbO2 are going to require an extra step. So start off the same. Write out your names. Iron is a transition metal, so leave yourself an open parentheses. Oxide. And reverse crisscross once again. So you end up with Fe +2, +1, +1, +1. There's no subscript next to the O, so that number is 1. O -1. No subscript next to the iron, So it was a -1. But if you check the periodic table, you see that oxygen is in group 16, which means it's supposed to have a charge of -2. However, right now it's got a charge of -1. So we need to fix this. And the only way to do that is to multiply the charge on oxygen by 2. What we do to one, we have to do to the other. So we're going to multiply both charges by 2. And so we're going to see that Fe now has a charge of +2, and oxygen a charge of -2. Now the charge on oxygen is right, which means that now the charge on iron is also right. We had to multiply that one by 2 as well. And we're going to put the Roman numeral 2 in parentheses. So it's going to be iron 2 oxide. Take a second and try to do PbO2, number 4 there. Try to do PbO2 on your own. Did you get lead 4 oxide? If you didn't, here's what you should have seen. Pb is lead. It's not technically a transition metal, it's a post-transition metal, but these also have the same weirdness as transition metals. Lead, open parentheses, oxide. Reverse, crisscross. You get Pb plus 2, O minus 1. But of course, that's a problem. Just like we saw earlier, oxygen is supposed to have a charge of -2, not -1. So multiply both charges by 2, and now you get Pb plus 4, O minus 2. 2 goes to both the -1 and to the positive 2. You get plus 4, -2, and there we go. Lead 4 oxide. Now, when you're naming compounds, when you're taking the name of the compound and you're writing the chemical formula, it's a whole lot easier when it's a transition metal because there's no guesswork. You've got the Roman numeral 2, which means that copper, Cu, has a charge of +2. And fluorine, look that up on your periodic table. You see it's in group 17, which means it has a charge of -1. Crisscross, and you see it's Cu, don't write the 1, F2. Try silver 3 oxide real quick. What should be the chemical formula of silver 3 oxide? Did you get Ag2O3? If you didn't, here's what you should have seen. Ag is silver, and the Roman numeral 3 means that the charge on silver is +3. Oxygen is in group 16, which means it's got a charge of -2. Crisscross your charges, and you get Ag2O3. Try these two. Potassium bromide and calcium fluoride. Did you get KBr for potassium bromide? This is the same rule as what we did before, because potassium is not a transition metal. Potassium can only form an ion of +1, and that's it. Calcium, same thing. Calcium is in group 2. It's an alkaline earth metal, which means it can only form a charge of +2. You should have gotten CaF2 for that one. If it's not a transition metal or a post-transition metal, the rules we learned first apply still. What about the names of these guys? Ki and AlCl3. Did you get potassium iodide for number 1? Same rules as before, and we do not need to put a Roman numeral in parentheses next to potassium because potassium is not a transition metal or a post-transition metal. Similarly, we do not need to put a Roman numeral next to aluminum because aluminum only forms a charge of +3. That's it. What about the chemical formulas for iron 3 bromide and lead 4 chloride? Roman numeral 3 means it's got a charge of +3 on the Fe. Bromine always has a charge of -1. When you crisscross, then that means that we're going to get an invisible 1 next to Fe and 3 next to Br, FeBr3. With lead chloride, the 4 as a Roman numeral means the charge on lead is +4. Chlorine, group 17, has a charge of -1. Crisscross, and you get PbCl4. Try these two. Fe2O3, HgF, meaning the names of those two. When you reverse crisscross, you find that iron gets a charge of +3, oxygen a charge of -2. Oxygen is supposed to have a charge of -2, so the charge of +3 on iron is correct. Number 2, HgF. Hg is mercury, F is fluoride, and when you reverse crisscross, you get a charge of +1 on the mercury and a -1 on fluorine. Fluorine is supposed to have a charge of -1, so the charge of +1 on mercury is correct. Try these ones out real quick. Writing the chemical formulas of these four. You should have gotten for number 1, HgF. For number 2, CuO. +2 on copper, -2 on oxygen when you crisscross and then reduce. Divide them both by 2, you get to CuO. For number 3, you should have gotten Hg3P2. And for number 4, you should have gotten MnS2. +4 on manganese, -2 on sulfur, crisscross, and then reduce. Now we're going to move on to polyatomic ions. Polyatomic ions are ions that are, as you can see, composed of more than one atom, which is why they have the name polyatomic ion. Ion made of more than one atom. Polyatomic ions have special names. They all travel as a pack. They have special names. If you look on the back of your periodic table at the common ions chart, the middle column and the far right column have a bunch of polyatomic ions. There are more than these, but these are the ones that are going to be most common in this course. If there are others that we'll use, then I will give you them. One that is not on there that I do want you to add is hydroxide. It is OH, the charge of -1. Notice, by the way, that on your table here, they don't always give you the -1. In fact, they usually just do a negative in the chemical formula itself, even though they tell you as an oxidation number it's -1. If it's a negative and just the negative sign, but you don't write the 1, that means -1. Now, when you are writing the name of ionic compounds that include polyatomic ions, you don't change the name of the polyatomic ion. It's just the name of the metal, unchanged, the name of the polyatomic ion, unchanged. when you are going from the name of the compound that includes a polyatomic ion to the chemical formula, you're going to write the polyatomic ion in parentheses and then crisscross. Any suffix, any subscripts go outside the parentheses. You don't change anything inside the parentheses. So let's see how this works. This is what a compound with a polyatomic ion looks like. Notice, by the way, that we've got Al, and then inside the parentheses, we've got NO3, and then outside the parentheses, 3. This means that we've got an invisible 1 next to aluminum, so 1 atom of aluminum. And this 3 outside the parentheses here, it means that there are 3 polyatomic ions of this one, NO3. When we're writing this out, you'll look at your periodic table and see that Al is aluminum. And then you're going to look on the common ions chart on the back of your periodic table for NO3. You'll find that it's called nitrate. Check and make sure that aluminum is not a transition metal and that you don't need to put anything in parentheses between aluminum and nitrate. It is not, and so you don't. And that's it. Aluminum nitrate is the name of this compound. Let's try this one. We got aluminum is our metal. And then inside the parentheses, we've got PO4. And outside the parentheses, we have nothing. There's an invisible 1 there, outside the parentheses. However, when this is a situation when we got a polyatomic ion where you've only got 1 of this polyatomic ion, which, by the way, is called phosphate, then we don't write the parentheses either. You can erase the parentheses. So this one, the way it would typically be written down is AlPO4. And you have to recognize that aluminum is the metal, which means that PO4 must all go together as a polyatomic ion. Look it up on your common ions chart, and you see that it's called phosphate, and there you go. Go ahead and try these two. For number 1, you should have gotten ammonium sulfide. And for number 2, sodium sulfate. A lot of these polyatomic ions end in either ATE or ITE. IDE is always a single ion, a single element ion. When you're writing chemical formulas for polyatomic ions, put the polyatomic ion in parentheses, put the charge outside the parentheses, crisscross, and write the subscripts that go with the polyatomic ions outside the parentheses. So, like this one, sodium carbonate, Na, in parentheses, look up carbonate on your common ion sheet, and you see that it is CO3 with a charge of -2. Crisscross. Oh, forgot to put the charge of sodium, +1. Crisscross, and you get Na2 CO3 1. Since there's just a 1 outside it, we can get rid of the parentheses, and there we go. Na2CO3. We did not have the parentheses outside the CO3 because the charge that would come down here outside it would be 1, and so we can get rid of the parentheses as a result. Let's do another one. Ammonium chloride. Look up ammonium on your common ion sheet, common ions table on the back of your periodic table, and you'll find that it is NH4. That goes in parentheses. The charge is +1. That goes outside of the parentheses. And then use your periodic table to find the charge on chlorine. It's in group 17, which means it has a charge of -1. Crisscross. And you're going to end up getting 1 and 1. So you can drop the parentheses. It becomes NH4Cl. Let's try another one. Magnesium nitrate. Use your periodic table to get the symbol and charge on magnesium. Magnesium is Mg, and its charge is +2. Nitrate. Use your common ions table on the back of your periodic table to get nitrate is NO3. Put that in parentheses. The charge is -1. Put that outside of the parentheses. And crisscross. You're going to get Mg with an invisible 1 next to it. But now, outside of the parentheses, we're going to have a 2, which means we got to keep the parentheses. NO3, and then outside the parentheses, 2. When I'm saying these chemical formulas, the way I typically say it is MgNO32. And that means that the NO3 is in parentheses, the 2 is outside of parentheses. Go ahead and try these two on your own. Write the chemical formulas of these two, of calcium phosphate and magnesium peroxide, using the common ions table to help you get the formula and charge of the polyatomic ions. calcium phosphate, you should have gotten Ca3, and then in parentheses, PO4, and outside of the parentheses, 2. Calcium has a charge of +2. PO4 has a charge of -3. Crisscross, and there you go. For magnesium peroxide, you should have gotten a charge of MgO2. Mg has a charge of +2. Peroxide is O2 with the charge of -2. So in parentheses, you put the O2, -2 outside. This is worth going over. Mg, charge of +2. Peroxide is O2 with a charge of -2. Crisscross becomes Mg2, O2, 2. And it's only these two subscripts that you can reduce. When you divide by the same number, only divide these two subscripts by 2. You do not touch anything inside the parentheses, including this 2 on the oxygen. That leads you here. So that's it. I hope you guys doing well this week as we're remote, and I'll see you guys next week. Take care.